Hey guys, today we're talking about rotations and rotational symmetry. So if we look at these two shapes, we're trying to figure out how many rotational symmetries they have and what they are. So symmetry is when you can cut a shape and it reflects and looks like itself, while rotational symmetry is when you can literally rotate the shape and it becomes the same shape. So, for example, with this star, if we look at the green dot, we're going to take this and we're going to see how many times it still looks like the star. So here it doesn't, but here it does. So 1, 2, 3, 4, 5 rotational symmetries. Okay? And the rotations are here, 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 and here. So it has 5. If we look at this one, start at the green dot, 1, 2, 3, 4, 5, 6. And the rotations that we would make would be 1, 2, 3, 4, 5, and 6. So this one has 6 rotational symmetries. Okay, so you try these. How many rotational symmetries does each figure have, and what are they? Go ahead and pause the video and try it. Okay, I'm going to show you. When we rotate this figure, it looks like itself here, 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 and here. So it has 1, 2, 3, 4, 5, 6 rotational symmetries. If you look at this heart, it has none. It only goes back to itself, so we don't consider this to have rotational symmetry. If we look at the X, like the one we just made, it has 1, 2, 3, 4. Okay, and so let's label them as 1, 2, 3, 4, and I always circle my last one so people know that that is my 4th rotational symmetry. Here's a little bit of a challenge for you that I'd like you to bring to class tomorrow. Create at least one object that has rotational symmetry and list those symmetries on the back in pencil. You can get as creative with it as you want, but please don't give me like a basic shape, like a square, a rectangle, or a triangle. Add some definition to it a little bit. Okay, so go ahead and try that for me and bring it to class. Okay, so let's talk about rotations. A rotation is a transformation that turns each point of the figure the same number of degrees around a common point. So, for example, if I was rotating this one and I rotated it into this quadrant, I rotated it 90 degrees clockwise. If I rotated it this way, its image would have been rotated 90 degrees counterclockwise. And I'm going to abbreviate clockwise as CW instead of CC. I don't know why I did that. I was thinking counter. So sometimes we say it's counterclockwise. If it rotated even further, though, in either direction. So if we start here and it rotates 90 degrees, then what does it rotate here? 180. So this would be 180 that way. Or if we started here and went this direction clockwise, it's still 180 in the same location. So we don't have to say clockwise or counterclockwise. It's just a 180-degree rotation. Okay, so what are the algorithms? Make sure you have this written down. For example, if you were to rotate it clockwise by 90 degrees, the numbers would change like this. The 6 and the 2 switch locations. So if 2 is your y, it's now your x. If 6 is your x, it's now your y. And then we make the y a negative. So if we look at the algebra form, notice that they've swapped the x with the y. That doesn't mean that the coordinates have changed, like the structure of the coordinates have changed, just the numbers. So like we said, if this was like a 3 and a 2, now this is 2 and 3, but this one's negative. Okay? Counterclockwise, the numbers still flip-flop, but the x coordinate has changed to a negative. So if you notice, the 5 becomes the y, and the 3 that was the y becomes the x, but the x is negative in both of these, while up here the y coordinate was negative. Okay, so let's try one applying these algorithms. Okay, we have NMLK. Let's first figure out what the points are. So try to determine what the points are and what it would be if you rotated it 90 degrees. Remember, you're switching the coordinates and multiplying the x coordinate by -1. Okay, go ahead and pause the video and try it. I'll be back in just a second to show you the answer. Okay, so we've got the coordinates here. N would be 1, 3, M would be 2, 3, L would be 3, 1, and K would be 1, 1. Okay, so the image would be rotated, so all the x coordinates need to be multiplied by 1 after we have switched the x and the y. So if you look here, I would flip-flop the n, the 3 and the 1, and then make the new x negative. Flip-flop, negative, flip-flop, negative, flip-flop, negative. So it would look like this. Okay, what about 180 degrees? Remember, we are rotating it about the point of origin. So this is going to rotate down here. The way that we use this algorithm is we leave the numbers x and y the same, but we make them both negatives. So if the point was 4, 1, it would now be -4, -1. So make sure you have the numbers and the algebra written down. Okay, so let's try this one. Go ahead and pause the video and see what you think. I'll be back in just a second to show you the answer. Okay, so here's what the coordinates would look like. F, G, and H would each be these right here. So we need to multiply both of these by a negative. So a -1 becomes a +1, and a +1 becomes a -1. 0 is still neutral. 3 becomes -3. 3 becomes -3, and 1 becomes -1. So it should look like this. And that is a rotation of 180 degrees. And that's all I've got for you, so make sure you have those algorithms, and I'll see you next time.